This is my FSR circuit. Here is the FSR, the force sensing resistor. This is a voltage divider circuit with a brown, black, orange 10k ohm resistor. This resistor connects in series with the FSR sensor. One side of the voltage divider circuit connects to the power, the red line. In this experiment, the power supply provides 6 volts. The opposite side of the voltage divider circuit connects to ground. As you can see, the ground voltage traces back all the way to this blue wire. I'm supposed to use a black wire to show its ground. The junction point between that 10k ohm resistor and FSR connects to a green wire. This is the output of this circuit. A multimeter as well as an oscilloscope later will connect to this output wire. Okay, now I'm going to connect the equipment to this circuit. Here I have all the equipment connected to the FSR circuit. This red cable provides 6 volts to the circuit, and the black cable provides ground voltage to the circuit. This green wire provides the output signal. It connects to a scope probe. The other side of the scope probe connects to channel 1 of the oscilloscope. A second green wire connects the same point here to a multimeter. The multimeter can display a more accurate reading. Okay, so as you can see, the DC multimeter shows the voltage is about 5.998 volt. And this is that force sensing resistor. Currently there's nothing on it. Now before we run the actual experiment, I'm going to just play with the sensor just to give you a sense about how it works. Okay, so I'm gonna apply some force here. As you can see, I put some force and then the voltage drops, same as the yellow curve. It drops. If you can see, currently it shows 25 milliseconds. How about let me change that to 1 second per division. 1 second per division. Okay, now let me try again. Okay, we just did a quick test. We can start working on the actual experiment now. With an instant money spells that I learned in Dr. Wang's theater class, instantly I have access to these 5 piles of quarter coins. Woohoo! Each pile has 5 quarter coins. Together there are 25 coins. In the experiment, I'm going to transfer 1 coin to the FSR at a time to see the change in the FSR's voltage. Currently, the oscilloscope is set to be 1 second per division. I'm going to change this to 50 seconds per division.
Wow, it's very nice.
Now we can begin the experiment. I'm gonna put the first coin on the sensor. Here, the first coin on the sensor. It's about 5.999 volt. How about let me put the second coin here. The voltage drops. It drops to 5.82 volt, and it is keep dropping. It's keep decreasing. 5.79 volt. Wow.
Okay, so that's keep decreasing. Let's just wait a little bit until it's more stabilized. So 5.74 volt. Okay, still decreasing. It's still not stabilized yet. The key for running a successful experiment, after this experiment, is to be patient.
Voltage drops to 5.7 volt. Let me add the third coin. Here.
Okay, the voltage is 5.54 volt, and that is still decreasing. 5.505 volt. 5.4 volt. Okay, 5.484 volt. The number is still decreasing. When can that become stabilized? 5.473 volt. Just need to be patient.
Okay, let me add the fourth coin.
The fourth coin added to the sensor. The voltage drops to 5.1 volts, and that voltage is decreasing. It's still decreasing. The number is fluctuating. The voltage fluctuates around there, and this meter is pretty sensitive. It can measure up to 3 digits up to the decimal point. So the reading is 5.03 volt, and I believe very soon it can even below 5 volt. Okay, it's almost there.
How about let me add the fifth coin. Okay, so here is the fifth coin.
So we have 6 coins, 5 coins on the sensor. The voltage is around 4.43 volt, decreasing crazy just like before. We're always decreasing. 4.44 volt. Okay. 4.39 volt. Well, 4.38 volt. Okay, let me add the 6th coin. This will be good, I think.
4.35 volt. How about let me add the sixth coin. Here.
4.1 volt. The voltage drops to 4.0 volt, and it is still decreasing. 4.06 volt. 4.0 volt. I believe very soon it can drop to below 4 volt. There, 2.99 volt. Oh, come on, get back to 4 volt. It just fluctuates around 4 volt.
Okay, let me add the seventh coin.
So 7 coins on the sensor now. 7 coins, voltage drops to 3.61 volt. 3.5 volt. 3.58 volt. And it's still decreasing to 3.55 volt. Oh, 3.54 volt. Oh, 3.53 volt now. Come on, this time it's pretty rapid. It drops rapidly. 3.52 volt. This 7 coins on the sensor. Okay. How about let me add the 8th coin now? Or we should wait? Maybe let's wait a little bit more. 3.47 volt.
Okay, 3.47 volt. That's enough. Let me add the 8th coin.
With 8 coins on the sensor, the voltage drops to 3.27 volt. And this voltage is still dropping, it's still decreasing. 3.2 volt, 3.23 volt. Come on. Still fluctuate. This sensor, or this multimeter is so sensitive.
Well, we can say just 3.2 volt, right? That doesn't change. Okay, now let me add the 9th coin. The 9th coin on the sensor.
Voltage drops to 3.0 volt. Very soon it's going to be below 3 volt. 2.03 volt. 2.027 volt. Wow. 3.01 volt. 3.05 volt. 3.00. Oh, now it's below 3 volt. 2.999 volt.
How about let me stop here and then let me save this data. Click save. And then there, change here to there, save it. Okay, now click that and we can continue. This is having 9 coins on the sensor. The voltage is around 2.93 volt, 2.94 volt. Let me add the 10th coin on the sensor.
The voltage does not change a lot. If you don't look closely, you cannot see the change. But it's still pretty like a constant. Voltage is 2.81 volt.
2.81 volt. Okay. How about let me add the 11th coin.
So we have 11 coins on the sensor now. 11 coins. The voltage is around 2.7 volt, 2.70 volt. The voltage is still decreasing. 2.69 volt, 2.68 volt, 2.684 volt. Okay, 2.673 volt, 2.663 volt, 2.659 volt. It just keeps decreasing. When can this be stabilized? But now let me add another coin. Yeah, let me add another coin.
12 coins. So this is the 12 coins here. So now there are 12 coins on the sensor.
Now this 12 coins currently is 2.617 volts, and I'm pretty sure that voltage just continues dropping. It's not stabilized. It fluctuates all the time. That is pretty strange, I think. 2.572 volt, 2.567 volt. It just goes up and down, fluctuate. 2.55 volt. Okay, 2.547 volt, 2.541 volt. Come on. The sensor is too sensitive, too emotional. 2.537 volt. Okay. 2.528 volt, 2.523 volt.
2.5 to 19 volt. Okay, let me add the 13 coin. So 13 coins.
Now there are 13 coins on the sensor. With 13 coin, the voltage now is 2.435 volts. 2.421 volts, 2.417 volts. Yeah, just like usual, it just keeps dropping. One can just never be a constant. Come on. 2.390 volts. Huh. This is a very long experiment. I remember I did before, it took about 40 minutes just to complete one experiment. Currently it's 2.374 volts. Yeah, this experiment is very time consuming. 2.359 volts. Okay.
Kind of stabilized now. 2.355 volt. Let me add the 14th coin.
Now there are 14 coins on the sensor. The voltage drops to 2.29 volt. It did not drop a lot. 2.272 volt. 2.264 volt. 2.253 volt. 2.244 volt. It keeps dropping. Okay, 2.24 volt. 2.234 volt. How about if you just keep one significant digit? If you just keep one digit after the decimal point, that is easy. 2.2 volt. Period. That's it. Unfortunately, we need to use more digits just to get a more accurate reading.
2.217 volt. How about now let me add the 15th coin.
We have 15 coins on the sensor. And it's around 2.151 volt. 2.12, 2.14 volt. 2.129 volt. Wow, if you look at the yellow waveform, it's reached to almost the last grid. I need to change this waveform now. Okay, so let me go to click the run and stop button, that. And then save the CSV file first. And then that one, save to image. Okay, so run this again.
Currently, there are 15 coins on the sensor, and the voltage is 2.073 volt. Let me get the 16 coins. So this is the 16 coins on the sensor now.
The sensor has 16 coins. The voltage is around 2.08 volt, 2.06 volt, and the number is still decreasing like usual. 2.048 volt, 2.039 volt. Okay, 2.03, 1 volt. This time looks like this number gonna drop below 2 volt. Let's just wait a little bit longer to see if it can be below 0, maybe it can be below 2 volt. Looks like it can. 2.014 volt now. Oh, close, very close. 2.007 volt. 2.00576 5 4 6 4 3 2. There, close. There we go. Go back. 2.0 now is
1.996 volt. Let me add the 17th coin. So we have 17 coins.
with 17 coins. The voltage now is 1.957 volt. 1.937 volt. 1.921 volt. 1.915 volt. 1.90 volt. Okay, let me add another coin. Should be
The 18th coin. So 18 coins on the sensor.
So we have 18 coins on the sensor. The voltage drops to 1.862 volt. 1.845 volt. 1.844 volt. And that number is decreasing, still decreasing. 1.836 volt. Okay. 1.832 volt. 1.830 volt.
1.827 volt. How about let me add the 19th coin.
So 19 coins on the sensor. With 19 coins, the voltage is 1.816 volt. 1.805 volt. Okay, well it's below 1.8 volt, now it's 1.791 volt. And it's still dropping. 1.784 volt. 1.776 volt.
That's crazy. 1.770 volt. Okay, now let me add another coin. So this is the 20 coin.
With 20 coins on the sensor card. Voltage is 1.750 volt. That's the voltage across this FSR sensor. 1.734 volt. Okay. Now it just takes too long for this experiment. But this is not that bad. Currently we only spend 25 minutes. Once I spend over 55 minutes.
We just have 5 more coins left. Okay, now let me add the 21st coin. There, 21 coins.
There are 21 coins on the sensor. The voltage across this FSR sensor is 1.67 volt. And the number is going to change. 1.663 volt. And it's still decreasing. 1.657 volt. 1.654 volt. 1.647 volt.
But let me add a 22th coin, 22nd coin on the sensor.
Okay, it's almost there. There's no coins left. With 22 coins on the sensor, voltage is 1.625 volt. 1.620 volt, 1.615 volt. That's good. 1.61 volt. 1.604 volt. The number is still decreasing. Quite stabilized now. 1.598 volt. At the time I say the number and then it changed. 1.954 volt. There we go.
With 22 coins on the sensor, the voltage across the sensor now is 1.579 volt. Now let me add the 24th coin. No, not 24. This is 23rd coin.
We have 23 coins on the sensor. Voltage across the sensor is 1.573 volt. As you can see, the more coins we add to the sensor, for each additional coin, the voltage does not reduce that much compared to less coins on the sensor. The more coins they put there, less voltage changed. Okay, 23 coins, the voltage is 1.555 volt. Let's just take 2 more readings and then we add another coin. 1.555 volt.
1.551 volt. About we have 24 coin. Coins on the sensor.
The voltage is about 1.544 volt. 1.535 volt. 1.53 volt. 1.524 volt.
It's about 1.520 volt. Now let me add the last coin. There. The 25th coin.
Voltage is around 1.505 volt. It's still decreasing. 1.495 volt. 1.492 volt. 1.485 volt. Let's just wait a little bit longer. 1.484 volt. 1.481 volt.
Okay. 1.48 volt. 1.477 volt. This is the end of this experiment. As you can see, now I add a 100 ohm resistor in parallel to the FSR. We still use the same output over here. So this green wire connects to the same multimeter and oscilloscope. Now we're gonna examine what's the change to the behavior of this circuit. Now these circuits connect back to the multimeter and oscilloscope. The multimeter shows the voltage across the FSR drops to 0.060 volt. Open sesame, more money. Instantly, I have another 25 coins. Thank you, Dr. Wang. This experiment, we are going to transfer all these coins, 5 coins at a time, to the FSR. To see what does the parallel resistor affect this circuit. Experiment begins now. The current voltage is 0.060 volt. I take the first pile of coins and put it on the FSR. The voltage does not change. Is 0.060 volt. Take the second pile of coins. The voltage drops a little bit. It's now 0.059 volt. Still the same, 0.059 volt. The fourth pile of coins. Same voltage, 0.059 volt. The last pile of coins. It does not change. Still 0.059 volt. Now I add a follower circuit to this FSR circuit. This follower circuit is made of using a 741 op-amp. To use this op-amp, first locate the dot. Put the dot on the left bottom corner, so the pin below the dot is pin number 1. 2, 3, 4, 5, 6, 7, 8. I use pin 6 connects all the way to pin 2. Pin 2 is the inverting pin of this 741 op-amp. And the pin 6 is the output of this op-amp. Pin 3 is the non-inverting pin. It connects to the junction between the resistor and the FSR. Pin 4, the negative power, connects to ground. And the pin 7 connects to VCC, 6 volt. This is the FSR circuit added to the follower circuit. We are ready to examine it. The FSR circuit with the follower circuit has connected to the multimeter and the oscilloscope now. With no weight on the FSR, the voltage is around 5.437 volt. Before conducting the actual experiment, let me just run a quick test to this circuit. To have a better sense about how this circuit is working, I'm going to change this 10 milliseconds to 1 second.
What's going on?
Did you notice? No matter how much force I apply to the sensor, the lowest voltage it can reach to is 1.967 volt.
I can do this all day. Yeah, I know.
It's time to begin the experiment. More money, please. Now I have these weights again, like previous experiment. I'm going to transfer the weight from here to the FSR sensor. Set the speed to 50 seconds per division. Okay, now it's 50 seconds per division.
You're the last one. Complete the mission.
The final experiment begins. Let me add the first coin to the FSR. The voltage does not change. It's at 5.437 volt. Added the second coin. .410 volt. Does not change too much. Add the third coin. There.
It changes to 5.33 volt. Still decreasing to 5.276 volt. 5.267. Yeah, it's keep changing. 5.255 volt. 5.244 volt. Okay, how about let's keep trying.
I'm going to add the fourth coin. The fourth coin to the sensor. Here.
Okay, now we kind of see a big change. It's 4.5 volt, 4.55, 4.53 volt, and that voltage is keep decreasing. And now it changed to 4.487 volt, and it's still decreasing. Let's just wait a little bit. We may need to wait a few seconds, or maybe up to a minute. 4.27, 4.21, then 4.40 volt. 4.40, oh wow, now it's lower than 4.4, 4.38 volt. Okay, I think it's time to add another coin. So it's around 4.36 volt.
Let me add the fifth coin.
So this is the fifth coin. The voltage reduced to 3.94 volt, and it's still decreasing. It keeps decreasing. Well, we just need to be very patient when we do this kind of experiment. 3.87 volt. 3.84 volt now. 3.82 volt. 3.81 volt. Still decreasing.
Okay, now let me add the sixth coin. So this is the sixth coin on the sensor.
The voltage is still decreasing. It drops to 3.48 volt now. And decreasing to 3.451 volt. 3.438 volt. And still decreasing. Continue decreasing. It's very hard to be stable. And it reduced to 3.41 volt. 3.41, 3.40 now. 3.40 volt. Oh wow, now it reached to 3.39 volt.
Okay, let me add the seventh coin. Here.
This is the seventh coin. It's about 3.15 volt, 3.14 volt. Let's wait a little bit longer until it's stabilized. 3.11 volt. Just need to be patient. Be very patient.
Okay, it's about 3.0 volt. Let me add the eighth coin. This is the eighth coin.
The voltage keeps decreasing. 2.95 volt. 2.93 volt. Okay, still keep decreasing.
Okay, let me add a ninth coin. So this is the ninth coin. There.
So we have 9 coins on the sensor. It is about 2.7 volt, 2.75 volt, and that voltage keeps decreasing. Keep decreasing. 2.741 volt, 2.73 volt, 2.72 volt, 2.71 volt now. Wow, this number just keeps fluctuating. Never stops.
Okay, let me add the 10th coin. So this is the 10th coin. Put it on the sensor.
We have 10 coins on the sensor now. The voltage is 2.63 volt, 2.61 volt, 2.6 volt, 2.59 volt.
Okay, it's time for me to save the data. So I'm gonna click stop here. And then going to save this. Okay, now let me add the 11th coin.
The voltage drops to 2.5 volt. 2.5 volt. Okay, still decreasing to 2.48 volt. And look at the pattern, most likely just keep dropping. It's unloading. 2.467 volt. And it still keep decreasing to 2.45 volt now. Wow, still keep decreasing. Come on, can you please stabilize the very soon? Gosh.
Let me add another coin. Here.
The voltage drops to 2.397 volt. 2.377 volt. And it's keep decreasing. 2.35 volt. 2.359 volt. 2.350 volt. Okay. 2.338 volt.
Add the 13th coin. So this is the 13th coin. There.
Okay, we have 13 coins on the sensor. The voltage drops to 2.267 volt, 2.262 volt, and it keeps decreasing. 2.23 volt.
Maybe it's time to add the 14th coin. So this is the 14th coin.
We have 14 coins on the sensor. The voltage now is 2.165 volt, and that voltage reading is still decreasing. 2.14 volt is around there, 2.144 volt. And if you look at the yellow line on the oscilloscope, you can barely see that change. But it's still decreasing. The pattern overall is decreasing, but not that much. 2.126 volt.
Let me add the 15th coin. So we have 15 coins on the sensor.
15 coin, the voltage reduced to 2.08 volt, 2.075 volt. Still decreasing, fluctuating around 2.063 volt. Come on, can you be stabilized soon? 2.054 volt. Okay, it's around there. I think I can take this reading. 2.044 volt.
So this is the 16th coin. We have 16 coins on the sensor now.
Voltage is 2.0 volt. Very soon it's going to be below 2.0 volt. Now there we go. 1.997 volt. It's below 2.0 volt. Now it's even below 1.99 volt. Close. There. 1.987 volt. Still dropping. But maybe the sensor is just too sensitive. It can read voltage up to 3 digits after the decimal point. Now it's about 1.91 volt.
Okay, now let me add one more coin. 17 coins now. 17 coins on the sensor.
How many coins now? 17 coins now. 17 coins on the sensor. The voltage drops to 1.968 volt. Well, looks like it's stabilized around there. That's not common.
1.967 volt. How about let me add 18 coins. With 18 coins, the voltage drops to 1.965 volt. Okay, 19 coins. $1.965 volt. How about 20 coins? Still the same. How about 21 coins? 22 coins. 23 coins. How about I put all of them? So as you can see, the voltage reached to 1.965 volt. So this is the end of that experiment.